Okay, so I have the pleasure of presenting the final topic in what we've called these GenTORE results, which can contribute to future-proofing European cattle production. And I'm going to talk about which cow in which environment and the tools that we've been working on to help address this issue. And because I'm also chairman, I can overrun without anybody standing up and threatening me. I did want to thank the people who helped me put this together, so Albin, Florian, Birgit, and Lotta, who worked hard to put this all together, and of course the whole GenTORE consortium who've contributed to this in lots of different ways. And what you should know is you're getting the live version of these four themes. There's also a document, a two-page document for each of the themes, which will be on the website. And behind that, there's a longer document where you get a link to all the different results that have been produced that contribute to that theme. So the idea is, once you've gone away from here, you can go on the website, you can pick this all up again, and you can tell all your friends what a fantastic read it is as well. Okay, so the context for which cow in which environment. So you're going to get a lot of repetition, but that's good, they tell us when you're teaching. Europe has an incredible mosaic of topography, weather conditions, farm types. And in addition to that, there's an increasing environmental variability which is coming, which may already be here, with climate change. So it's fairly evident there is no one-size-fits-all optimal balance between cattle resilience and cattle efficiency. We can imagine environments which are quite demanding, where animals need a good resilience, and other environments where they're much more protected and they need far less resilience. And likewise, some of those environments allow them to express a high efficiency and others won't. So what is the right balance? That's the question we're talking about here. So from a farmer perspective, which cattle is best for the current and likely future environments? So if you're a breeder, you just add geno. What genotype is best for current and likely future environments? And that includes also having sufficient resilience in your animals to cope with possible current and future disturbances. So if we want to answer that question, we have to consider a number of things. We have to actually understand and be able to characterize what is my current and future local environment. What kind of cattle do I have in terms of efficiency and resilience, because this is GenTORE? How will my cow perform in a given environment? So when I bring those two things together, the environment and the cattle. And then finally, what are my key levers to better match my animal to the environment? Now, of course, these are things you've heard about already in the different talks today, but we're wrapping up. So if we take that first question, what is my current and future environment? So GenTORE created a new farm production environment data set. This was done by combining European FADN data and meteorological data. So there are now two cattle data sets, one for dairy, one for beef, which contain a wide range of variables at regional level. So these provide the opportunity to analyze and estimate for particular regions or particular farm types, farm efficiency and farm resilience, and therefore to be able to start to identify what might be needed to adapt to future changes. These data sets are publicly available, so you can go on the website, you can find them, they can be used to ask questions about which environment you have. Just to give you a couple of examples of what can be done with those data sets. So this is a retrospective economic analysis. The graph is showing the gross margin change. So these are the losses in gross margin relative to the baseline of 2007 up through to 2013. What's evident on this graph is that in 2009 there was a drought, and that affected all of those lines. Each line represents a different farm type region. So you have North Atlantic, you have Southern Europe, you have uplands, you have boreal, and so on. What's interesting to us is that the extent to which these different regions responded is different, and how they recovered is different. So that's telling us that different regions and farm types can react differently to climatic disturbances. The second example was a forward prediction. This is a prediction of what might be the likely climate change effects as we go forwards. So in the panel with the graph, the top one is the current situation. going from light yellow to darker brown, it's the milk productivity levels in the different parts of Europe. The bottom two graphs are showing how things will change for 2030 and 2050. And basically, the more red it is, the worse it's going to be. These are based on available forage yields and the predicted impact of climate change on those forage yields. And what it's saying is, if you're in a yellow or a red region, you have a higher risk of suffering from forage shortage, and thus a higher need to adapt your systems and perhaps also your breeds to anticipate that change. So this is helping us to understand where are we heading with our local environments. The next question was, what kind of cattle do I have? So this has just been covered for the phenotyping very nicely by Claudia, so I won't talk about that other than to say we have tools which are helping us to phenotype resilience and efficiency. And exactly the same for the genomic tools, which Måns covered in the first talk. We have tools for improving genomic evaluation for crossbreeds and admixed, for G/E. So GenTORE is helping us and helping the breeding industry to have the tools to enable better selection in crossbreeding systems and within and across environments. Moving on to the third question, what happens when we bring those environments and cows together? So that's the G/E question. And again, this is something Måns presented, so I'll go quite quickly, that traditional genomic G/E, oops, we've lost the microphone, I believe. No, it's back. Anyway, I'll go closer. Okay, that's too close. So the traditional G/E genomic models assume similar effects of G/E across the genome, and of course that's something that we wanted to look into. So GenTORE has developed a pipeline. It's difficult to be here and read. A protocol and analysis pipeline will allow us to model somebody turn this off then before I do it all around? Yeah. So the question is that microphone off or am I going to deafen you all? We'll do that. Okay. So I won't present this again because Måns presented how this protocol works. I'll skip straight through and say that what we have is a modeling protocol that can be applied to multi-trait and to reaction norm models. It delivers genomic breeding values accounting for different G/E effects. The nice thing is it's based on readily available software, so it should be easy uptake by genetic evaluation centers. We've also looked at G/E in another context. So we have looked at systemic biology models to quantify G/E. So that's coming in from the other end. That's saying, how do animals function? Can we describe that in a way and model that, how that reacts together with the environment? So this is part of the work which Alben presented right at the beginning. These models explain how animals function by saying they have abilities to acquire resources, so how much their intake capacity, and then they have abilities to partition those resources between different life functions, which can be production, which of course impacts efficiency, and they can also be other life functions which impact the animal's resilience. And in these models, we include the biological mechanisms of how that work, but we also include genetic drivers. And we've already been able to show, and again, another graph you've seen before, that when you look at the allocation and acquisition parameters of the best cows, the profiles of the best cows in different environments, what you see is that they're not the same profiles for different environments. So that's suggesting that the best adapted animals are slightly different in different environments. So the last question which I asked was, which are the key levers which allow us to better match my animals to my environments? So the first thing we've done, and again, Alban presented this at the beginning, is to couple up this mechanistic model with a breeding scheme simulator. And that allows us to ask the questions, if we take a known set of animals with these acquisition allocation parameters today, we run them through, let's say, 20 years of selection, we can then look at what the allocation acquisition balance is in the future and look at what kind of gains we're getting and where we getting a good preservation of resilience, for example. And this is the results that Albin showed. And what we see here is that with this new prediction method, we can predict the performance of future cows, which are accounting for the potential energetic trade-offs. And then we can see what is the impact of selection on the resilience indicators, in this case mainly body reserve dynamics and lifetime efficiency. And then we can see the outcome of selection if the environment changes dramatically. So just a brief word about lifetime efficiency. For us, short-term feed efficiency is a kind of pure measure of efficiency. Lifetime efficiency, because the animal has to live longer, incorporates resilience. So a good lifetime efficiency is a good balance between resilience and feed efficiency. So that gives us a better insight into the underlying mechanisms, and we believe that's of interest to breeders for benchmarking different breeding strategies. And we've taken that a step further. GenTORE has studied the whole production system using life cycle analysis. It has used social life cycle analysis, so that's asking questions of how a system impacts the farmers, the workers, the community, society. And on the other hand, we've done environmental life cycle analysis. So that obviously relates to all the kind of environmental issues that Eileen was talking about. And the interesting thing is to combine those two. So that's what's being shown in this scheme here. If you combine the two, you can start to see where not only what we're doing in terms of bioeconomical modeling, but also in terms of the societal consequences versus environmental consequences come into play. And the idea is that such a tool opens up for a discussion with stakeholders on what it is we actually want to achieve, and therefore can be used to provide a better informed choice in building broad breeding goals. Now that all may seem like a pipe dream, like we've gone several steps too far and we've lost the plot. And these are indeed tools which are there for discussion. But the tools that we've developed in GenTORE have also included taking some of this information into on-farm ranking tools. So what you have on the screen here is a shot from a livestock market in Ireland, and what you could see down at the bottom if I had a pointer is that there is a value for the replacement index, and that is coming from a model developed within GenTORE. So in Ireland, they have been working for a while, and they've developed this cow's own worth index, which takes the genetics of the animal, incorporates any crossbreeding effects, adds in some of the individual performance of the animals where it's available, calving dates, because in Ireland we're in seasonal calving system, and the age of the animal, and that allows to give each individual cow a cow's own worth ranking, which can then be used for making decisions about culling or not culling, and it can be used for making decisions when breeding. Are we breeding replacement animals? Are we crossing off onto beef, and so on? Within GenTORE, the same thing has been done and extended and developed for female beef cows with a beef's own worth index and a beef future profit potential index. And these have actually now been deployed in Ireland and are being deployed in France. This was just to show you on the graph down here that if you look at the values predicted by the system in terms of economic worth along the x-axis, they match pretty well with the prices paid at market up on the y-axis. So these things are actually now getting out there. So GenTORE has come a long way. We started off with a black and white drawing. We now have colored things in. That's how we work in research. The conclusion, I would say, is that we have developed tools to evaluate the current and future match between genetic and environmental resources. We have tools which allow us to ask, is my current match good? What are the options for improving? And what can be the longer term consequences? Now, of course, it's only one 5-year project. We haven't solved everything in the world. Some of these tools are publicly available. Some of them are usable directly by breeders, for example, and advisors. Others are still research tools which remain to be developed. So I think there is going to be an after GenTORE where a lot of these things get worked through and taken further out into application. And with that, I will thank you for your attention.